Hi everyone, let's see this question which is an MSQ question. So this question is taken from Purdue University. So let's see what they are saying. They are saying let x be a uniform random variable in this interval which is 1 to 10. And now they have defined a new random variable y which is a function of x, which means y equal to x square. Now which of the following is or are true? That's what they are asking, right? So let's just see this. They are saying that p of, which means probability of y being between 1 to 2 is same as probability of y being between 3 to 4, and probability of x being 1 to 2 between 1 to 2 is same as probability of x being between 3 to 4. So I think this is true because of the definition of uniform random variable. So if you recall the uniform random variable which is defined for 1 to 10, it must be the continuous uniform random variable because this range is continuous, right? So this is from 1 to 10. Now what they are saying, this is x which is from, let's suppose, 1 to 10. Now if this is uniform random variable, then it means that this probability density function must be constant. So uniform random variable means that you take any range of the same interval, which means if you take 1 to 2 and you take 2 to 3, right? If that interval is same, if this is one length and this is also one length, if this interval is same, then it means the probabilities are also same. And that is true for x because x is a uniform random variable. But you don't know about the y, whether y is a uniform random variable or not, because y is a new function of x. We will see whether it is a uniform random variable or not. So you can say the probability of x being between 1 to 2, between you write equal to or not, it doesn't matter because it is a continuous random variable, is same as probability of x being between 3 to 4, right? So this is one thing that is for sure. So which means that B must be the correct answer. Now let's just see whether this A, C and D are correct answers or not. Let's just pick the option A and let's see if this is correct answer or not. So what they're saying, let me probably go to the next page. They are saying that y being 1 to 2 is same as y being 3 to 4. Maybe we can replace this y, so to be x square. So probability of y being between 1 to 2 is same as saying probability of x square being between 1 to 2, because that's the definition of y. And what does this mean? See, x square between 1 to 2, it means that x is between 1 to square root of 2, right? See, let me just tell you how it is happening. See, suppose if I say x square is less than 1, then when it is true, whenever x is less than 1, right, x is less than 1, which means like if I'm saying, okay, if I'm saying x square is less than 1, then it means that x is basically, you can, okay, maybe I will come to 1, but for example, let's suppose it is 4. So what does this mean? That x can be between -2 and 2. You pick any value from here of x, then you will be getting x square less than 4, right? So basically you will say that this means that x is between -2 and 2, right? If you pick any value which is -3 here, then x square is 9, which is not less than 4. Similarly, if you pick any value which is 3 here, then x square is 9, which is not less than 4. So if you pick any value between -2 and 2, then x square is actually less than 4. So which means x square less than 4 is same as saying x being between -2 and 2, right? And what does this mean to say that x square greater than some value, maybe let's suppose 9 or something? Then can I say that does this mean that x is greater than 3 and x is actually less than -3 also? See, if x square is greater than 9, if I say, then either x is greater than 3 or x is less than -3, which means if you pick any value, let's suppose this is -3, this is 3. If you pick any value which is greater than 3, maybe 4, then also 16 is greater than 9. Yes, that is true. Or you pick any value which is less than -3, which is -4, then also 16 is greater than 9, which is also true. So basically, if you have something like this, if you have x square less than 4, then it is between -2 and 2. If you have x square greater than 9, then it basically means this is greater than 3 or less than -3. Okay. And now if you talk about x being in any range, which means let's suppose that x square is being in any range. Let's suppose this is between 4 to, let's suppose, 25. Then what will the value of x? See, if you take the value of x between 2 to 5, then does this satisfy? Let's just see. If you take the value of x between 2 to 5, then does x square is 4 to is between the 4 to 25? Let's just check. So if you take any value here, maybe 3, then you will say that okay, x square is 9, right? So if you take any value here which is maybe 3 in between this range, then x square is automatically between 4 to 25. If you take x value 3, then x square is in between x square is 9, which is actually between 4 to 25. If you take any value here 1, let's suppose, which means that if you take value of x here in this range, then does this satisfy? Then no. If you take, let's suppose 6, then does this satisfy? No. Only on this range this satisfy. So which means x square being between 4 to 25 is same as saying x between 2 to 5. So basically, if that's in some range, then you can take the square root directly, right? You can take this 4 to 2. You can bring this 25 to 5. So that's how it works. Now coming to the question that we have, if x square is between 1 to 2, then you can take the square root of 1, which is 1. You can take the square root of 2, which is root 2, right? So x is in between the 1 to square root of 2. So now they are saying that the probability that y is in between 1 to 2 is same as y is in between 3 to 4. So probability that y is in between 1 to 2 is same as x is between 1 to square root of 2. Similarly, the probability of y is in between 3 to 4 is same as the probability of x square is in between 3 to 4, which is same as probability of x is in between square root of 3 to 2. Are these two probabilities same? If these two probabilities are same, then I will say that A is the correct answer. Otherwise, I will say A is not the correct answer. Let's just check whether these two probabilities are same. So basically, what I have arrived is actually this. So this left hand side is this probability, and right hand side is actually this probability in terms of x. So they have given in terms of y, but we have converted in terms of x. Now we need to check whether these two probabilities are same or not. And it is very easy to check. Why? Because this is a uniform random variable and we know how to check for the uniform random variable. See, for the uniform random variable, you know that the length should be same. This length is square root of 2 minus 1. This length is 2 minus square root of 3, which is not same, right? Which is not same. So it means what? That if these two are not same, if the length of the interval is not same, that's when the probabilities are also not same. This means that these probabilities are also not same. That's how you can check. Given was in terms of y, what you can convert that in terms of y to in terms of x, and then you can check. So that's why A is the wrong answer. Let's just check this particular option C. So this is between 1 to 3, which is already in terms of x. Now let's just check whether this is in terms of, we can convert this in terms of x. So it will be between 1 to 3, right? X between 1 to 3. Yeah, that is correct. So that's why C is the correct answer here. C is the correct answer. What about D? Let's just check. D is saying x is less than 2 and this y is greater than 64. Yeah, that's interesting. Maybe I can just copy this on the next page again, right? And let me just show you. See. So what is happening here, that we want to check whether this particular identity, this particular equality is true or not. So this is y greater than 64. What does this mean? Probability of x square greater than 64. What does this mean? That x must be between minus 8, this means that x is either greater than 8 or, so basically it means that x is either greater than 8 or x is less than minus 8. Right? So which means either greater than 8 or less than minus 8. And since x is defined between 1 to 10, so this support means like, this support is a technical term. So support means that if the PMF is 0, then you will say that support is 0. So basically here this particular value, okay, not PMF in this case, this is the probability. But anyway, let's not worry about it. So basically this particular probability is 0. Why? Because this random variable is taking the value from 1 to 10. So that's why this particular value is 0 and this is 0. So basically this is same as saying, so this is the probability of x less than 2, and then on the right hand side I have 1 minus, this is same as saying probability of x greater than 8. Now let's just check whether these two are true or not. So probability of x less than 2 does this same as 1 minus probability of x greater than 8. Let's just check. So see, for the uniform random variable, this is between 1, this is 2, and then this is 8, and then this is 10, right? So that's what it is happening. So probability of x less than 2 means this interval, which is okay, whatever the value of this constant, maybe it is c. We can calculate the value of constant. I think it should be 1 upon 10 minus 1 is 9, right? So it should be 1 upon 9. Yeah, it should be 1 upon 9, so that the particular this whole area is 1. But anyway, let's just keep it c. Okay, let's just keep it c. So this probability x less than 2 is basically, this interval is 1. So 1 into c, this probability is 1 into c. Is this equal to 1 minus Okay, let me put the value of c if that is required. But actually this is 1 minus x greater than 8 means x less than equal to 8, right? X greater than 8 means this probability, right? This probability. So I don't think this is actually equal, because this 1 minus x less than 8 is actually same as saying x less than equal to 8. So obviously these two are not equal, right? This is x less than 2, this is x less than equal to does not matter or equal, because this is the continuous random variable, and this is x less than equal to 8, this is x less than equal to 2. So obviously these two are not same. This is 8c, this is 8 minus 1, 7c, and this is 1c. Obviously these two are not same. So that's why D is also incorrect option. So you can say that D is also incorrect option. Okay, I mean incorrect. So basically B and C are the only correct options. That's very nice and very approachable question, and these questions are very much suitable for GATE. In GATE, regarding to particularly this continuous random variable, they do not ask very tough question, but this is not a tough question. This is a very nice question, I can say, right? It just requires you to basic definition of the uniform random variable, and that's how you can solve this question. I hope you liked it. So thank you so much. Thanks for watching.